Hi, welcome to Lesson 10.5, Angle Relationships in Circles. Now, before we begin, we are going to go on page 298, and I want you to glue a blank piece of paper right in the middle of it. And I want you to divide this into not necessarily 3 equal portions, because case 1 doesn't require that much space. We'll come back to the space in just a bit. So about this much space for case 1, case 2, and case 3, because we're going to be looking at 3 different cases for the tangent and intersected chord theorem. Now this is on page 298. Zoom out a little bit so you can see it. Now on page 299, I want you to glue another paper, and I want you to divide it in half. And the top one is going to be for the angle inside the circle theorem. And the other one is going to be for the circumscribed angle theorem. So we're not going to do full formal proofs on it, but I'm going to explain to you guys why it is that these theorems actually work. So let's begin first on page 300. Okay, now on page 300, let's talk a little bit about what these theorems actually are. Okay, the first theorem is the tangent and intersected chord theorem that states that the measure of angle 1 here is going to be half the measure of this arc right here. And similarly, the measure of angle 2 is going to be half the measure of this arc right here. Now, on page 298, we're going to look at why is this true. Now, let's take a look at intersecting lines and circles. And by the way, this is for example 1a and example 1b. Now, intersecting lines and circles. Now, 2 lines can intersect in various different ways, where the intersection could be either on the circle, inside the circle, or outside the circle. So if 2 non-parallel lines intersect a circle, there are 3 places where the lines can intersect, either on the circle, inside the circle, or outside the circle. And that's for problem number 2a. Now, the angles inside the circle theorem states that if 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Sounds very confusing, but honestly all it is that this angle here is the sum of this arc here and this arc here. And this angle here is the sum of this one and this one. And we're going to explore on page 299 why that is true. So once again, this is for 2a and for 2b. Now, the next theorem, we are not going to explore the why because it is a little complicated to explain, but I want you guys to understand how this works. It's actually not very difficult. If a tangent and a secant, 2 tangents or 2 secants intersect outside a circle, then the measure of each angle formed is 1/2 the difference of the measures of the intercepted arcs. In other words, if I wanted to find out what angle 1 here is, I would have to take the difference between this arc and divide it by 2. Similarly, I would have to take the difference between this arc and then divide it by 2 to get that angle. Now here, I would have to take the difference between this arc and divided by 2, and I would get angle 3. Now, core concept. A circumscribed angle is an angle whose sides are tangent to a circle. Now, we did learn that when that happens, we are going to have right angles right here, because a tangent to a circle is going to be a right angle right there. So let's go ahead and go back to page 298. Okay, so on 298, we're going to take a look at the tangent and intersected chord theorem. And we're going to look at 3 different cases. Now, the first case, it all has to do with where is the center. Is the center on the angle? Is it inside the angle or outside the angle? So that's what we're going to be looking at. So I'm going to try to zoom in so we can have enough visual of what I'm talking about. All right, so here is my first circle right there. Okay. Now, I'm going to have a tangent. Okay. I'm going to call this point right here A. I'm going to call this point right here C. And in this case, the angle is going through the center of the circle that I'm going to call this intersection right here B. Okay. So one thing that we need to know or remember is that anytime you have a tangent to a line, a tangent to a circle, the radius is going to be perpendicular to that. Okay, so we know that the measure of angle BAC is going to equal 90 degrees. Now, we already knew that. We also know that the measure of arc AB, well, AB happens to be a semicircle. So that right there is going to be 180 degrees. So therefore, half of that would be the angle. Okay, so the measure of A is going to be, hold on, what's that? So yes, like I was saying, the arc measure here, the measure of this arc is going to be 180 degrees. Now, if I divide this by 2, I get the following, okay? I get the measure of, half the measure of arc AB is going to equal to 90 degrees. Now, if you look at this right here, okay, by the transitive property, okay, of equality, I'm going to have the measure of angle BAC equal to 1/2 the measure of arc AB. Okay, take a close look at that. Okay, so therefore, angle BAC is going to be half the measure of arc AB. And we are going to use this in the second scenario because here the center was on the angle. In this next scenario, the center is going to be inside the circle. So let me go ahead and draw that. Okay, here we have our tangent. Here's A. We're going to call this one here C. And I have my angle going like this, B. Now, since the center of the circle is inside the angle, there exists a diameter that can go right through it. Okay, so I'm going to call this angle D. Now, we already know what this right here is going to be, so we're going to be using that in just a second. So we do know that the measure of angle DAB, based on our prior knowledge, was going to be half the measure of arc DB. And this is based on a prior theorem that we already covered, where this angle here is going to be half of the measurement of this. Okay, so we also know that the measure of angle CAD, that's this one right here, was going to equal 1/2 the measure of arc AD, based on what we learned up here. Okay, so CAD was equal to 1/2 the measure of arc AD. So now what we're going to do is we are actually going to add these two together. Okay, so when we add these together, we're going to get the measure of angle DAB plus the measure of angle CAD equal to 1/2 the measure of arc DB plus 1/2 the measure of arc AD. So now let's think about what this exactly here means. DAB plus CAD, that's the whole angle according to the angle addition postulate. That will be the measure of angle BAC. Now what I'm going to do is I'm going to factor 1/2 from this. Okay, So what I have here is the measure of arc DB plus, that's an arc right there. It's an ugly looking arc. Okay, plus the measure of arc AD. So let's think about that. That is DB plus AD. That would be basically the whole arc right there. So the measure of arc BAC, okay, is going to equal 1/2 the measure of arc BADB. Okay, so in other words, this whole angle here, this angle here is going to be half of all of this. Now, let's take a look at that third scenario. Okay, in the third scenario, the center is actually not on the angle. So it's going to look something like this. Okay, so it's going to look something like this. Okay, we're going to call this one here A, call this one here C, call this one here B. Now, for the same reason, since the center right here is not on the angle, there exists a diameter that can contain that center. We'll call that D right there. Okay, so we have the following. The measure of angle DAC, okay, DAC, we know that is 1/2 the measure of ABD. So all of this, okay, ABD. Okay, so once again, DAC is 1/2 this arc right here, ABD. We also know, based on a prior knowledge, that the measure of angle DAB, okay, DAB was going to be 1/2 the measure of arc DB. Now, instead of adding these, I'm going to go ahead and subtract these, and you're going to see what's going to happen here. Okay, so I'm going to see if I have enough space to do it on this. So the measure of DAC, fix my pencil. Okay, so the measure of angle DAC minus the measure of angle DAB is going to equal, now to save some space, I'm going to go ahead and factor out a 1/2 and write this down as the measure of arc ABD minus the measure of arc DB. Now let's think about what this means. DAC minus DAB is literally going to be this angle BAC. So that's going to equal angle BAC, and that's going to be equal to 1/2. Now look at this. Arc ABD minus DB is going to be this piece right here called AB. So the measure of AB. Okay, so once again, we reiterate the fact that this distance right here, let me get my highlighter. Okay, this distance right here, this angle right here, okay, it's going to be twice this angle measure right there. Okay, and on this one, this right here is going to be twice the measure of this angle right there. And similarly on this one, this right here is going to be twice that right there. Okay, so take a minute and finish writing it down. Pause the video if you need to. All right, once you're finished, go ahead and move on to page 299. Now on page 299, we're going to investigate the angle inside the circle theorem. Okay, so it looks like a complicated theorem, but honestly, it's really not that bad. So we're going to first start off with a circle. And in that circle, you're going to have two chords that intersect each other, like this. Not necessarily at the center. Okay, so we're not even going to bother putting the center right there. I'm going to call this point right here A, D, C, and B. Now, I'm going to call this one here angle 1, and I'm going to call this one right here also angle 1. Now, I'm going to create a triangle from this measurement right here. Now, I want you to see something right here. I'm going to mark this angle here with 1 arc and 2 arcs right there. Now, based on prior knowledge, we have the measure of angle ACB. Okay, the measure of angle ACB is going to be 1/2 of this measure right there. So 1/2 the measure of arc AB. Sometimes I ran a little too fast. Now, for the same reason, the measure of angle DBC, that's this one, DBC, is going to be 1/2 of CD. 1/2 the measure of CD. Okay, or DC, however you want to put it. Now, here's what we're going to look at. We're going to look at the exterior angle theorem. Okay, I don't know if you remember this, but we did talk about these two angles right here. Okay, being an exterior angle, not being an exterior angle, but the exterior angle is the sum of these two right here. So one of the things that we learned way back is that the measure of angle 1 is going to be equal to the sum of these two angles. Well, what are the sum of these two angles? The sum of those two angles are angles ACB and angle DBC. So now what I'm going to do is I'm actually going to substitute. Okay, so I'm going to substitute these right here for these right here. So that's going to be 1/2 the measure of AB, arc AB, and 1/2 the measure of arc CD. I'm going to factor out my 1/2, and that's going to be 1/2 plus the measure of AB plus the measure of CD. So really think about what this means. Okay, think about what this means. This means that the angle 1 here in question, this one right here, okay, that one right there, is going to be half the sum of arc AB and CD. So really, if you want to find out that angle, all you have to do is add the two arcs that get intersected and divide it by 2, and you get that angle. For the same reason, this angle right here where my pencil's at is going to be half the sum of the two intersecting arcs. Okay, don't mind the bell, guys. I am in my classroom recording. All right. The next one, the circumscribed angle theorem. Now, this one's a little bit more simple to explain, but basically, it states that if you have a circle, okay, and you have a point on the outside, and you have these to be tangents to the circle, okay, like this. I'm going to call this angle D. I'm going to call this here point A, and this one here B, and center C. Okay, what we have in this theorem tells me that this angle right here, this one right here, angle D, is going to be 180 minus the central angle. Okay, so 180 minus central angle. So why is it that that's true? Well, for one, the radius of a circle, they're all the same. If I was to draw a diagonal right there, okay, by the way, this is a right angle, and so is this because they're tangents. This right here, CD, is going to be congruent to CD by the reflexive property of congruence, therefore making these two triangles congruent by hypotenuse leg. Okay, so just think about that. Now, also, another thing that we have to look at is the fact that the sum of the angles right here is going to be, 360. So we're going to have the following. The measure of angle D plus the measure of angle ACB. I'm even wondering if we even needed that. okay, is going to equal to, plus 180 degrees. That's going to equal to 360 because that is a quadrilateral. So the measure of angle D plus the measure of angle ACB is going to equal to 180 degrees. Okay? All right. Now, the reason why I did this is, I guess, to show that it's a quadrilateral, but I honestly don't think we even needed that. I don't know why I showed you guys this. So ignore this. You don't really need it. Now, what I did have to show you guys was this was a right angle right there. So ignore this. I thought I needed it, but no. I need it for something else, though. Okay, so you have a quadrilateral. Okay, we know that this angle here and this angle here plus 180 degrees, so it's going to equal to 360. Now, why 180 degrees? Because that's 90 and that's 90. That's where I got the 180 degrees. Okay, so I subtract the 180 degrees from both sides, and I get that the measure of angle D and the measure of angle ACB is 180 degrees. So when I subtract the measure of angle ACB from both sides, you get that the measure of angle D is going to be equal to 180 minus the measure of angle ACB. But what is ACB? ACB, okay, this is the central angle. Okay, that's the central angle. All right, so that is the circumscribed angle theorem that states that this angle right here is 180 minus the central angle. All right, so finish copying that off. Then once you're ready, let's go ahead and begin the examples. Okay, so let's go ahead and go to the examples. So if you did not catch where the examples go, this is where they go. 1A, 1B, 2A, 2B. It's on page 300. And then on page 301, you're going to put 3A, 3B. Okay, let's not forget about these. Okay, go back and review these. And we are not going to do example 4. I did not quite like example number 4, so kind of ignore it. We're not going to need it. And that's the extra practice people were going to do. So let's go ahead and begin the examples. Okay, now in this example, this is example number 1. So go ahead and pause the video and write that down. It says line M is tangent to the circle. Find the measure of the red angle or arc. Now mine, they're orange because I don't really have a red highlighter. But let's go ahead and figure out what this is going to be. Now one of the things that we did learn was that this angle right here was going to be half of this arc. So the measure of angle 1 is going to be 1/2 the measure of arc AB. Now, arc AB is 130 degrees. Okay, so the measure of angle 1 is going to be 130 degrees. Divide that by 2. Okay, so 130 divided by 2, that's going to be 65. Okay, on this one, we have the measure of angle KLJ is going to equal 1/2 the measure of arc KJL. Now, according to this, they actually give me the angle, and they want me to find out what that arc is. So that's going to be 125 degrees. Okay, and then we have the measure of KJL. So in order to solve for that, we actually have to multiply both sides by 2. Okay, so 125 times 2, that's going to give me 250. And that's the measure of KJL, of the arc. That's this right here. All right, and that takes care of example number 1. Let's take a look at the next example. Okay, in this example, we are going to look for this angle right here. Okay, so we know that x is going to be 1/2 the measure of arc KL, and let me put that in here, and 1/2 the measure of JM. Okay, so let's take a look at this. Okay, so X is going to be 1/2 the sum of 156, KL 156, and JM 130. So 156 plus 130. Okay, now 156 plus 130, that's going to be 286. So 1/2 times 286, that's going to give me 143. Okay, so X is going to be 143. Okay, now on the next one, okay, we know here, let me divide this. We know here that X right here is going to be 1/2, okay, of the difference between this one and this one. Okay, go back and look at the theorem. Okay, so it's going to be 1/2 the measure of arc AD minus the measure of arc BD. Okay, so we have X is equal to 1/2, and the difference between these two is 178 minus 76. So that's going to be 1/2 times 102, okay, which means that X right here is going to be 51 degrees. And that is example number 2. All right, on the last one. Okay, so in this one here, we need to remember that this angle right here is going to be half the measure of the central angle. So X is going to be 1/2 the measure of angle ACB. Okay, so in this case, ACB is 135. Okay, so 135 divided by 2. The application to the problems are actually way simpler than you think. 67.5. Okay, take a minute and make sure you write that down. Wait, I think I did something wrong. Hold on. No, I didn't. I did use the wrong theorem. Okay, see, this is what happens when you go ahead of yourself. All right, I totally used the wrong theorem. Okay, so the theorem, okay, goes like this. And I should have slowed down. Okay, so the measure, or X, we can say, X is going to be 180 minus that central angle 135. Okay, so slow down, Asuna. 180 minus 135 is actually going to be 45. So X is equal to 45. I knew that didn't seem right because it wasn't even the same theorem. So X equals 45. I'm only human, guys. I make mistakes. I'm not perfect. Near perfect, but no. Nice kidding. Okay, so let's take a look at the next step for this one. Okay, our goal is to figure out what is X. But before I do that, I need to figure out what the heck is this right here. Okay, what exactly is that angle right there? So I do know that 30 is equal to whatever 180 degrees is minus the measure of angle EGF. Okay, so what I'm going to do is I'm going to add the measure of angle EGF to both sides. Okay, and that's going to give me the measure of angle EGF plus 30 equal to 180 degrees. Now, when you subtract 30 from both sides, you get the following. Okay, that gives you 150. So what does that mean? That means that this angle right here is 150, which means that this arc right here is also 150. So this part right here is 150. Okay, you can barely see that. But that arc right there, let me highlight it. This arc right here is 150. Okay, that's that one right there. Now, that's not the answer though, because they want me to find out what x is. Now, we do know that x is equal to 1/2 the measure of arc EF. Okay, but we do know what that is. Okay, that right there is 150. So therefore, x is going to be half of that, which is going to be 75. All right, so ladies and gentlemen, this concludes lesson 10.5. Thank you for watching. Here, let me center so you can copy it.